Hi guys, this is Sajjad Hussain again. Now we have seen that STAAD is quite capable of analyzing these structures. We saw the analysis capabilities and the results are verifiable. Now I want to check the design capabilities of STAAD. I will start with the steel design. Let us check the design of the steel beam. I am using these design examples by AISC. Its version is 13.0. I'll take an example of simple beam design. This example is f dash 1 f.1 dash 1a, and this is a W shape flexural member and designed in a strong axis bending, and this beam is continuously braced. The given conditions are that this beam is a W shape and the material is ASTM A992 and the span is 35 feet. They limit the member to a maximum depth of 18 inch. Okay, and the deflection limit is L by 360. The nominal loads are defined like dead load is 0.45 kip per running foot and live load is 0.75 kip per running foot. So let us start our model. If you see the solution, we will be using allowable stress design method. Here the moment is 184 kFit, and because of the deflection limit L upon 360, the allowable deflection is 1.17 inch. To have this deflection, the required moment of inertia comes out to be 748 inch 4, and it is proposed that we can use W18 by 50 as per the table 3-2. So let's check what the results are coming from STAAD. Let us start new, plane, steel beam in flexure. Units are feet and kip. Okay, finish. Let me close. Node number 1 will have a coordinate 0, 0, and since it is 35 feet long, so node number 2 will have 35, 0, 0. Let us join these two. And both these are simply supported pin connection. We assign pin supports to these nodes, and let us assign W 18 by 50 16, 16, 18, 18, well, 18 by 50, assign, right. Let us define the loads. Load number 1 is dead load. We can assign member load minus 0.45 kip per running foot, and we can add live load. That's minus 0.75, and let us assign these loads. And this one also. Okay, let us save. Now we can define a load combination. Since we are using allowable stress design, so our load combination will be simply addition of these two. Okay, so we have added load number 3, load case 3, which is a combination of both the loads. Add perform analysis, no prints are needed. Then we will go to design phase. And design, of course, we will select steel. And steel we will select allowable stress design. The parameters, all parameters are already selected. Let us define, okay, let us change the units, inch and kip. Let us define the values Fy and Fu. Fy is 50 KSI. Fu is 65 KSI. Let us assign. Okay. Now the condition is that beam is constantly braced. What does it mean? In STAAD there is a provision UNB and UNT. UNB means unsupported length of the bottom flange, and UNT is unsupported length of top flange for calculation of bending capacity. As you know that this beam is continuously braced, that means this beam is supporting some slab. That's why the top flange is constantly supported. Let us assume that this top flange is supported at every 12 inch. Sorry, there are. Then we have to add check code. Let's suppose analyze. Okay, no error, no warnings, no notes. Let's see the output file. So the result shows pass, and the stress ratio is allowable to actual is 0.751. Okay, that's very good. So let's go to post-processing. We don't want all the forces, we just want only combination. Okay. So first let us see the deflection. Let us magnify the deflection. See the results, view value, beam, displacement. The displacement here comes out to be 1.737, whereas the allowable deflection was only 1.17. That means we are not meeting this criteria. Okay, let's see the moment. Beam, result, view value, beam, bending, maximum 184 kip. That means it is exactly correct, but the deflection here is more. Okay, let us see the properties of this section. AISC is 800. In our calculation, it has been used yes, exactly, which is less than 784. That means this deflection is little, and STAAD the deflection is higher. Okay, so let us see one more thing. Go to design, modeling, design. Let us define one more parameter, that is called deflection. This is the deflection ratio, maximum to allowable. There is one more thing. This deflection is for live load only. Yes, exactly. It's not for dead load. So we cannot check this deflection against dead load. This dead load is for live load, because the deflection criteria is applied on the live loads, not on the dead loads. So what we have to do, we can perform our analysis one more time, and let's do something here. After checking the code, we can say yes. Load list 2. Perform analysis. and let us define our parameters once more. The deflection is L upon 360. Fy is 50. Fu is 65, and unsupported length is not more than 12 inch. Okay. Assign to view. Assign to view. Assign to view. Yes, assign to view. And then we can say check. Okay, so analyze once more. View output, and this time it passes and the ratio is 0.93. That's the correct approach. Now we can go to post-processing. Only for load case 2. And here we can see that beam let's see the bending value. Now for the live load it is only 115 kip feet, and because of that the deflection is, let's see how much is the deflection. So the deflection comes out to be 1.085 inch, which is less than 1.17 inch. That means we can meet the criteria. So the lesson learned is here that if the beam is continuously supported on the top flange, then we have to define U and T, and because of that the beam will qualify, otherwise it will not. Say for example, let us change this value, or let us put a comment card asterisk before it. It will be read as a comment card. That means this condition will not be applied. If this is this so, then the beam will not qualify. Let's run. No result, no error. Select, inspects all failed beams, the beam fails. So this is very important, that if the conditions are given For the lateral support, we have to define our lateral support conditions. And to define the lateral support conditions, we have these parameters UNT and UNB. Let me remove these asterisks so it will be there. So now, gentlemen, you saw that STAAD is very good in designing the steel structure. A beam can be safely designed, a steel beam can be safely designed with the STAAD, no problem at all. We did not see any problem. Hopefully you like my tutorial, and please don't forget to subscribe me. Thank you very much.